In the next few lessons we're going to look at lenses and imaging. In this lesson we're going to look at some important definitions. So we've got a thin converging lens here, and in most of the work on imaging we'll be looking at thin converging lenses. Now first of all, there's an axis which passes through the centre of the lens. This is known as the principal axis, and it may also be known as the optical axis. And every lens has what is known as a principal focus. Okay, so we'll mark this is the principal focus of the lens, and we'll call that f1. And all lenses will have, in fact, two principal focuses either side of the lens. We'll call this principal focus f2. And how do we determine this principal focus? Well, we can do this by taking two rays that come into the lens parallel to the optical axis. Okay, so we trace these rays up to the center of the thin lens. And the center of that thin lens is called the principal plane. Okay, so we've got one ray coming from above the axis and another ray from below the axis. We draw those up to the principal plane, and then these will then be refracted or bent through the principal focus of the lens. Okay, so any rays approaching our thin converging lens, which are parallel to the optical axis, will be bent or refracted through the principal focus of the lens. Likewise, if we were to trace these rays from the other direction, from the right to the left, then they would be focused through the other principal focus, f2. Okay, so the distance from the principal plane through to the principal focus is known as the focal length of the lens. And the distance from the principal plane to the first principal focus f1 is exactly the same as the distance from the focal plane to the second principal focus f2. These distances are the same. Okay, in the next lesson we're going to look at various imaging problems involving thin converging lenses.